Welcome to another edition of RCE. I'm your host, Brock Palin. I have, again, Jeff Squires from Cisco Systems and OpenMPI. Jeff, thanks again.
Good afternoon, Brock. What do we got today?
We have with us two people who work on the ROX cluster distribution. At least that's what I think it is. I'll admit, I'm familiar with it, but I've never used it myself, so I'm flying blind again. They are Greg Bruno and Mason Katz, and they're both at UCSD. So, guys, welcome to the show.
Hi, I'm Mason Katz. I work at UCSD. I've been here for about 10 years working on the ROX cluster distribution project. Prior to that, I worked at University of Arizona doing network security, writing network operating systems. It was a lot of fun. And prior to that, I was a 8-bit embedded developer. So I'm a big fan of the accumulator.
The good old Z80. My name is Greg Bruno. I have a very similar background to Mason here for the last 10 years. I hired on 1 month before so I always remind him about how I outrank him in seniority. But prior to that, I was working at NCR, where they build and still continue to build the world's largest databases there using Teradata technology.
Okay, guys, thanks a lot for taking some time. Can you give us a quick rundown on what ROX is meant to accomplish, and therefore explain what it is? When you say a cluster distribution, expand on that.
So that's a good question, because we've had this question internally for many years. Our first release in November 2000, we called ourselves the ROX Clustering Toolkit, and that was a name that we put together. The toolkit part was added by Greg and my own boss, Phil Papadopoulos. Last name should be familiar. And at the time, we were a toolkit because we were really a layer of tools that went on top of an existing machine and then allowed you to deploy a cluster. And over the years, we've become more and more automated, more and more turnkey, and now we're really more of a distribution. We're more of a cluster on a DVD. So you can pop it into one node, turn it into a master for your system, and just one by one bring up your compute nodes with zero human interaction. But we'll get into the details of that more.
Okay. So what's the history? Where did ROX come from? How did it get started?
Actually, Mason and I met Phil Papadopoulos prior to working on ROX in another lab that was here at UCSD. So all three of us were hired in to work for a PI there, where he was investigating Windows clusters. So this was in 98?
99.
Yeah, 98, 99, when he was investigating Windows clusters. And so we all came on board, and we were all Unix heads, so we were really out of our element. And so we were trying to use a lot of the windowing tools in order to, basically put a Windows distribution down onto all the compute nodes reliably. They had all these programs that did like multicast, that none of them worked reliably. And Phil one day said, you know what, I'm just going to make a partition on every node, and it's going to run Linux. And at that time, it was Mandrake. And so anytime we wanted to reimage the entire cluster, Phil ran a program out there that told the nodes go boot back into this one Linux partition, and then basically just do a DD in order to splat all the new bits down. So that was really kind of the prototype of, if you want to reliably build back-end cluster nodes at any sort of scale, Linux is your horse.
So what exactly is ROX? Is it middleware? Is it an operating system? Is it a distribution? How exactly would you classify it?
It's all of those. ROX includes all of the software you need to go from bare metal to fully functional, application-ready computational appliance. So ROX, for example, includes all the relevant bits from CentOS. It includes middleware for cluster monitoring, such as Ganglia. It includes middleware for Grid, such as Globus, or did at one time. So it's everything. We actually have referred to it many times as kind of the hypodermic. This is the hypodermic you use to inject software onto your bare metal. So it's just it's the methodology and it's the technology to wrap all that up, OS to application, treating everything the same. Applications are treated no differently from the OS. It's just how do you bundle everything and get it deployed. So technology-wise, it's really a distribution, but it includes components from operating system all the way to application, including the middleware. That's a fuzzy answer.
So Ronen, give us a sample scenario, right? So you mentioned a really high level one before. You pop in a DVD on a head node and you bring up compute nodes. Give us a little more detail on what a common scenario is that you see your users doing.
Well, let's go to the simple answer of just a HPC cluster, an MPI machine. We'll have people that they buy a few nodes from a tier 1 vendor. They have their front end node. They talk to their network admin, get an IP address, simple stuff like that. They go to our website at www.roxclusters.org. They pop in the DVD, turn on the machine. They answer a few questions. It's just like installing Red Hat. It's actually a little easier because we remove a lot of the installation screens. And they just put in their IP information, time zone, password. Hour later, the front end comes up. They run a very simple command on the front end when they first log in called insert ethers, and they turn on these slave nodes that are all on a private, non-internet routed network. And they just automatically come up. And it takes about 10 minutes a node. You do them a few seconds apart from each other. So really in a matter of 2 hours, you can go from a room full of 32, 64 nodes and boxes to a fully functioning MPI machine. And that's always been our target. That's where we started. We started funded as NSF funded NPACI program to make it easy for researchers to build and manage their own MPI machines. And we moved past that, but that's where we started, and that's really what we're best at still.
Okay, and so when you say it's about 10 minutes per machine, I assume this means a disk full load. So you're blasting an OS and some level of middleware and software and other things like that, and that must include loading it onto the machine itself, or what?
Yeah, that's right. I mean, we do all of our installations are from bare metal, and so there's a lot of benefits there. One of them is that when you start from bare metal, or you're actually starting from the empty set, and so when you start from the empty set, that's known, right? You know what the machine was going to do when the amount of software in the set is empty. And then as you start to build up, you're going from known state to known state to known state to known state. And so at the end, the configuration and the characteristic of that machine is fully known because you started from a known state and you transitioned all the way through known states. Another benefit of having the disk out there on the node is, simply just to cache the operating system and also to cache applications. So if you're running at scale, having that disk drive there in order to help the nodes, relieve the pressure of the network just to go out and grab some files or some common files or some read-only files, we found that to be a huge benefit.
So in the religious debate of diskless versus disk full, it sounds like you guys are coming down on the side of disk full.
Well, I don't think it's a religious debate. It's what do people prefer. We've chosen as a group just not to worry about the diskless problem. We understand that people care about it, and we've collaborated with one group, Kesasart University, good friends of ours in Bangkok, who created a diskless role. So they did add diskless support to ROX. The project there that they were with is no longer funded, so that's some support that went away, but for us, it's not a religious argument. We're very open to diskless. It's just not something that we've focused on.
Okay, fair enough.
You mentioned the word role in there. What exactly is a role?
So a role is a meta package, really. It's the easiest way to think about it. It's a meta package, but it's not just configuration and bits for one machine. It's a meta package for your entire infrastructure, for your cluster, for your data center even. Because in that role, you have individual packages, and in the context of Linux, they're RPMs. There's a little bit of XML in there that's actually maps directly to whatever the automatic installer language of the OS is. And in the case of Linux, that's Kickstart.